Good morning, students. Today we are going to discuss about the PCB preparation. In this lesson, on completion of this period, you would be able to know about brief explanation of the PCB preparation. Next one is the photo processing technique for the PCBs and method for etching, cleaning and drilling for the PCB designing. And also we discuss about the steps involved in making the double-sided PCBs, and the other topic is principle of soldering, and in the soldering what are the different materials we are using for the soldering, and the soldering alloys, soldering fluxes, soldering methods also we are going to discuss. In the soldering method we try to briefly discuss about the iron soldering, mass soldering, dip soldering, drag soldering, wave soldering methods are emphasized, and also at last we discuss about the PCB specifications. So these are the things we are going to discuss. Let us see how we prepare the PCB. You can see the diagram, PCB preparation process, how it is, that is represented simple way. You can see in the black diagrammatic way. Now you see what are the different steps to prepare the printed circuit board. In the last previous classes we already discussed about the different basics of the PCB designing. What are the different laminates, what are the different materials, what are the different layouts, what are the different printings, how we print, what are the different artworks. All these are discussed in the previous classes. Now we are going to discuss overview of the PCB preparation. You see, the black diagram states that first we having the layout preparation. Whenever you want to design a PCB, you try to develop the layout first. The circuit layout we need to prepare. After preparing the layout is converted into the artwork already we discussed. In the artwork we having the different methods are there. From the artwork it is converted into the film master preparation. Film master preparation, from the film master it is transferred to the copper clad lamination. Copper clad lamination, from the copper clad lamination it is going to the board cleaning. After copper cladding we try to clean the board. After board cleaning we go for the printing. After printing we make the plating on the our printing. After platings we try to etching the unwanted things. After etching we make the machining operation, that is making the drills and holes by using the different machines. After that, at the final we try to fix the components, and after fixing that we make the solder the component leads. By this we complete the PCB preparation. Now we try to discuss one by one. You can see. So layout preparation, you know already the layout preparation. Layout of a PCB is the pencil sketched component and conductor drawing on a white paper or a graph sheet, that is called as a layout. The layout of the PCB has to incorporate size of the circuit, the track position, pad size, input and output connections of the circuits. The next block is the artwork. The artwork. The artwork is nothing but first step of the PCB preparation is the artwork. In accurate registration, two critical spacings are due to bad artwork. The meaning is if the artwork is not proper, the critical spacing between the two conducting layers are may get the damage. After artwork, the next one is the film master preparation. Film master preparation. The film, negative or positive, used for the direct exposure of the photoresist coated PCB or the light sensitized screen is called film master. The dimensional accuracy, sharpness, wear out, resistance will equally apply for a film master. The film master make the basic photofilament for the printed circuit board. The next block diagram is the next level for the PCB is the copper clad lamination. A laminate can be simply a product obtained by pressing the layers of filler materials impregnated with resin under heat and pressure. Commonly used fillers are the variety of papers or glass. Different types of laminates are we use the phenolic laminate, epoxy laminates and polyester laminates. These laminates are used to get the copper clad lamination. This provides the conducting path in the printed circuit board. How we provide these laminate means the laminate can be simply a product obtained by pressing the layers of a filler materials impregnated with the resin under heat and pressure are called as a laminations. The next level is the cleaning, board cleaning. The, the cleaning of the copper surface prior to resist application is an essential step. Insufficient cleaning causes many difficulties in PCB fabrication. It avoids the poor resist adhesion, uneven photoresist films, fin holes, poor plating additions, etc. These are eliminated by proper board cleaning. Whenever we clean properly, the copper surface is cleaning is proper, then we get the proper PCB. After cleaning the board, we try to print. The printing is there, already we know that the printing is the process of transferring of the conductor pattern which is on the film master onto the copper clad base material, that is called as a printing. What we are doing is conductor pattern which is in the film master, that is transferred to the copper clad base material. This printing is two types, that is the photo printing and the screen printing. Already we discussed about this photo printing and the screen printing. We know the what is the photo printing. Photo printing, you know that photo printing is extremely accurate process. This printing is used in the semiconductors and integrated circuits are fabricated using this process. It is used in professional applications. Next one is the screen printing. You know the about the screen printing. Screen printing is comparatively cheap and simple method. It is less precise than photo printing. Majority of PCBs produced worldwide are screen printed. This method is used where accuracy and precision is not important. After the printing, next level is plating. So we now printed the whatever the conductor patterns are there on the copper clad base, we printed the conductor patterns. Next one is the plating. In order to protect copper tracks, plating is necessary. Applying solderable metal over the copper tracks is known as the plating. The meaning is solderable metal over the copper tracks is known as the plating. Metals like tin, nickel, gold are used for the plating. The next one is the next level for in the PCB is etching. The etching means the final copper pattern is formed by the selective removal of unwanted copper. Removal of unwanted copper which is protected by etch resist is known as etching. In the simple way, we can say that removing of unwanted copper on the PCB is called as a etching. The etching is done in the different techniques are there. Different etchings are ferric chloride, cupric chloride, chromic acid are used for etching the unwanted copper. The etching is very important because this process makes the conductor patterns as realistic. When the etching is proper, then we go for the next level, that is called as the machining operation. The machining operation is nothing but the drilling is an important machine operation. Drilling is used to create the component lead holes and through holes in a PCB. The machine operation means after getting the conducting patterns with the copper cladding, now we try to design the leads with the holes, and all this is called as a machine operation. At final, after getting these drilled lead holes and the remaining mounting necessary needs are completed, the final stage of the PCB is the component fixing and soldering. Now we try to fix the components and solder the components. Now carefully assembly of the PCB is very important for final equipment reliability. Lead cutting, soldering are the important processes. So the meaning is after putting the leads and the holes, we need to properly cut the leads and properly solder the leads are the important. PCB cleaning after soldering is important. Commonly used chemicals are acetone alcohols, aromatic hydrocarbons. These are used in the cleaning the PCBs. So these are the different steps for the preparing the PCB. Now let us discuss photo processing technique. Already we discussed about the photo printing. Briefly, I try to recall what we discussed in the previous class. Photo printing. Photo printing is the process of transferring of the conductor pattern which is on the film master onto the copper clad base material using the photoresist. This is called as a photo printing. Photo printing is extremely accurate process. Already you know, semiconductors and integrated circuits are fabricated using this process. It is used in professional applications. The steps involved in photoresist printing, you can see the some steps. We try to recall these, already we discussed. The pre-processed board is laminated with photoresist material. Example is the Kodak photoresist. Photoresist can be either in liquid form or as dry film. Photoresist is exposed to ultraviolet light. It hardens or polymerizes photoresist. Polymerized part is insoluble to certain chemicals, solvents known as developers. The developers dissolves the portion which is masked or which is not exposed to ultraviolet light. This is transferred to a master film on 1:1 scale. Next one is the image transfer. How the image is transferred. The image transfer process is the process of transferring of pattern to a mask which is kept on the PCB. Film processing unit, you can see how the film is processing in the dark room. You can see in the diagram. So how it is, the PCB is coated with photoresist. Copper pattern is overlaid. Resist is developed. Good copper is uncovered after resist is washed off. You can see the visual 3 in the laminate. After that we having the photoresist material is there, copper clad is there. Wherever we require, there we having the copper clads are there. Next you can see them euro plate is there. Thus in the euro plate, similar process to electrolysis, but a charged bath is used. Thicker deposit of copper, the traces, holes and pads become thicker with copper on top of the existing copper. This is called as a euro plate. Another one is the tin plating exposed. The traces are then plated with a thin layer of tin. The tin will be used as an etch resist in the next step. The photoresist is then removed. You can see the photoresist. After ending, we are getting the copper patterns. Copper patterns. After the tin plating exposition, then we go for the chemical etching. The unwanted copper or uncovered copper is then chemically removed of the board. That is the etched from the board. This is called as a etching. The tin is then stripped off. At this point, the board is functionally ready. At this point, the board is functionally ready. You can see the board. We having the unwanted copper is removed from the board. The removed process. The removed process uses the methylene chloride solvent at temperature of about 20 degrees centigrade or a solution containing sodium hydroxide at a temperature of 60 degrees centigrade. Why can't the traces be made thin? Electrical signals will travel through these traces. Etching removes unwanted copper but also removes a small amount of copper under the tin plating. That is undercut. The SN may remain on the board, the tin may remain on the board, but it is typically removed to avoid solder mask over solder. You can see that unwanted one is gone, but some of the portion of the needed copper clad also removed. Next one is the solder mask. How it is? Solder mask covers areas where solder flow is not desired. Where the solder flow is not desired. LPISM, that is a liquid photo imageable solder mask. We use the LPISM, that is the liquid photo imageable solder mask is used to develop like photoresist from before. Uncured mask will wash away, leaving a solderable surface, leaving a solderable pad. LPISM is applied to the entire board and the board artwork is overlaid. The image is developed onto the mask. The undeveloped areas, typically only the pads to which parts will be soldered, will wash away, leaving most of the board still covered. The pads are pure copper at this point. Other types of solder masks are also used, including a laminated dry film and screen printed. In either case, the pictures tell the story. You can see the sample plating, how the plating on the board is there, copper clad is there, and that we are making the photo printing. After photo printing, you see here the clad material, we are making the printing. The overall conclusion of this is, you can see how it is. Photo printing is the process of transferring of the conductor pattern which is on the film master onto the copper clad base material using the photoresistor. The conductor patterns directly gone to the copper clad base. Photo printing is extremely accurate. It is used for the semiconductor integrated circuits and its professional applications, and the film negative or positive used for the direct exposure of the photoresist PCB. We already discussed about the etching. The etching, you know what is the etching? Etching is chemical process by which unwanted copper is removed. We already discussed. Once again we try to get the etching. The final copper pattern is formed by the selective removal of unwanted copper, which is not protected by an etch resistance. Etching is one of the most important steps in the preparation of the PCB. Already discussed what type of etchings we are using. Dried PCB is washed with ferric etchants. The different etchants available are ferric chloride, cupric chloride, chromic acid. Already we discussed these are the etching elements. What is the etching process? We try to discuss the etching process. The etching process is immersing a board in an etchant solution and agitating. Insufficient etching results in excess copper present on the board, causes short circuit between the tracks. Over technique results, it can result into broken tracks of thin tracks. So these are the different conditions in the etching process. The thing is, for the etching what we are doing is, we make the board is immersed on the etchant solution. In the etchant solution, that solution may remove the excess copper but also causes the but also causes the broken tracks of the thin tracks. So we try to take care to avoid those things. Materials we are using for printing and etching, you can see the materials are copper clad, and then we are using the, that is a circuit film. We are using the circuit film. Placing of a PCB in etchant. You see here how we are wetting the PCB in the etchant solution. You can see like that. So we are placing in the PCB in the etchant in the C. You can see the figure. After few hours, what happens? You see here like it is. So what are the etchant we are seeing already? Ferric chloride, cupric chloride, chromic acid, and alkaline ammonia we are using. You can see already we seen this one. So these are the different advantages of the ferric chloride. Which one is there? The advantages you see here. What type we are using? We have each chloride having its own advantage. So these are the etching. Next, industrial etching machine, you can see. So how it is. So in this we make the PCB on that. So the etchant will remove the unwanted copper. So etching. After etching, what we are going to do? After etching, we are going to cleaning process. Cleaning process starts. We try to cleaning. How we can clean? In cleaning process, the ferric chloride contaminated surface should be cleaned. By using the etchant, we remove the unwanted copper, but it may also add some slurries on the board that should be removed in the cleaning process. How they are cleaning, you can see in the visual. Cleaned PCBs here, how we are getting with a detailed copper clad patterns, conducting pattern is here. After cleaning, we are going for the mechanical operation process starts. Already we discussed machining operation. What is the machining operation? Machining operations are drilling, and making the drilling is to create the component lead holes. Already we discussed. After getting the cleaning and final PCB, now we are going to ready for the drilling. We can see the drilling, how we can drill. The drilling should not harm the laminates. They should not harm the board. Should not eliminate the solder position. Should not eliminate the conducting patterns. So that should be done in a proper way. So drilled PCBs, you can see PCB is now ready for the soldering. That is, in addition to component holes, via holes are also required for providing mechanical connections, heat sinks, assembly or connectors to the board. All these are need to connect. The drilling can be done before or after the track areas have been defined, depending on the manufacturing sequence. The thing is, after getting the cladding only, we need to get the drilling. We may have the before drilling or after drilling also there, depending on manufacture sequence. We can drill the holes. So what are the different machines for the drilling is, generally we use the hand drilling machines or CNC machine also we can use for the drilling. In the industrial application, we use the CNC machine. This is the etching machine. So these are the some conclusions about the our etching process. Now we are going to discuss about the double-sided through hole PCB. Double-sided PCB, we try to discuss a short. Double-sided boards have copper tracks on both sides of the board which are to be interconnected. Double-sided PCB means both sides we having the copper tracks are there and the both tracks should be interconnected. So like that we need to use them. Double-sided PCB can be made with or without plated through hole. Via holes are the holes utilized only for through contact and not for component mounting. Not for the component mounting. Via hole you can see plated through holes. The plated through holes PCB production is expensive. Plated through holes are chosen where complexity and density does not leave any other choice. The total number of plated through holes in particular via holes should be kept minimum for economy and reliability. You can see the double-sided PCB board. For the general understanding, you try to see this double-sided PCB board. How it is there, copper plated through hole is there, copper track is there, the copper. The top layer has been patterned in align with the bottom layer. Holes are drilled through board and then copper is electro deposited to interconnect top and bottom layers. We having like this. You can see generally copper foil. Copper layer can then be patterned into circuitry, generally done by photolithography as discussed previously. On a double-sided laminate, both layers are patterned and aligned on a top of each other for subsequent interconnections. So another with is no plated through holes board. Double-sided PCBs without plated through holes cost factor is considerably lower since plating can be avoided. Laminate, you can see there is no copper conductor is there, solder joint is there, no plating, we don't have any under plate, we having the no plating, no plated through hole plating is there, no plating is there. Through contacts are made by soldering the component leads on both the board sides. Jumper wires may also be added. Hand soldering must be used for soldering of the component side joints. You can see the layout design of the no plated through holes board. So these are some of the things for the two-sided double-sided PCBs. Now we see here. So try to understand the two-sided steps involved in making double-sided PCBs for your understanding purpose. Cut the board to correct size and punch tooling holes. Clean the board surface. Electrodes plate through holes. Electroplate through holes. Apply photoresist material. Expose to UV through negative of artwork. Negative of the artwork. Develop the image. Spray etch non-tracks areas. Remove the photoresist. Inspect the board. Apply solder resist on the plate edge connectors. So print etch process for the double-sided PCBs are same. Now see here lightly you can see what happening in this. So base material double-sided how it is. From all the base material like this we having the things are there. You can see before film is exposed to UV like this we having two-sided one. For your understanding, you use this one, two-sided. We having like this, we get the two-side copper pattern. So these are some conclusions at the conclusion of the two-side PCB. Double-sided PCB can be made with or without plated through holes. Plated through holes are chosen where complexity and density does not leave any other choice. The total number of plated through holes, in particular via holes, should be kept minimum for economy and reliability. Double-sided PCB preparation steps are completed and PCB is ready for testing. So generally double-sided PCB are somewhat complicated. Once one side is completed, the same procedure is done for the both side of the PCB. So now final step for the PCBs are the soldering. The soldering is important when we mount the components on the PCB. We need to solder properly. How we need to solder them? Soldering is a process for the joining of metal parts with the aid of a molten metal, that is a solder. Molten metal, that is by using the solder we try to joining the metal parts with the board. The melting temperature is maintained below that of the material joined. What material we want to join, the melting temperature should be less than that particular material. Thereby surface of the parts are wetted without them becoming molten. Without being, that is molten. That is called as a soldering. Soldering is very important. Soldering is a process for the joining of metal parts with the aid of a molten metal. You can see soldering have been in use since time immemorial. Solder was used in making the what that is the different things for the soldering. You can see making jewelry, join the lead pipes for public baths. Today we can put most of the solder application into the three major groups: mechanical joining, sealing, electrically conductive joining. So these are different types of soldering: mechanical joining, sealing, electrically conductive joining. And like electric joint threading, the third group is used in electronic applications. Different applications of the solders, we try to see different applications of the solders. You can see the figure. So making a jewelries, mechanical joints. You can see that is the third one is the electrical conductive joining. So what is the principle of solder connections? Soldering is a process for the joining of metal parts with the aid of a molten metal. Melting temperature is situated below that of the material joined, thereby surface of the parts are wetted without them becoming molten. Soft soldering or soldering generally implies the joining process occurs at temperature below 450 degrees centigrade. The filter metal or the filler metal wets and alloys with the base metals and gets drawn by capillary action into the gap between them. This process forms a meteorological bond between the parts of the joints. Solder acts by like this, wetting of the base metal surfaces forming the joint, flowing between these surfaces, which results in a completely filled space between them. Metrological bonding to these surfaces when solidified. The general steps involved in the soldering operation you can see. Relative position of the surfaces to be joining, wetting of these surfaces with the molten solder, allowing the solder to cool down until it has solidified. You can see the solder flux base metal. So events during the wetting of the solder joint, you can see what are the events we are doing. First we need to apply the heat, and then copper. You can see the solid soldier, and next you can see the copper oxide. Next you can see copper in compound, solid flux, boiling flux. You can see molten solder, plastic solder, like that. These are the different solder wetting. Contaminated surface soldering, you can see how we are getting. Now we can see copper oxide. A drop of molten solder on contaminated surfaces will behave like an isolated drop of mercury. After solidifying, this drop can easily loosen when subjected to mechanical shocks. The quality of the electrical contact in such case will be poor. The current has to pass through more or less insulating oxide film. Cleaning the surface soldering, you can see base material, properly wetted solder joint. You can see diffusion layer, molten solder. If the surfaces are clean, wetting take place and solder will flow across the surface. The solder atoms are now able to come very close to the atoms of the base metal, hence they are attracted. The solder thus gradually diffuses into the solid metal and provides a good adhesion. The different metallic contact with the atoms of these metals ensures a good electrical contact. After discussing about the principle of solder joints, let us discuss about the soldering alloys. What are the different soldering alloys? You can see soldering alloys are special alloys which are used to get either mechanically strong joint or electrical joint with low contact resistance. Soldiers have low melting points with the liquids temperatures below the melting point of pure lead, that is the 327 degrees centigrade. The bulk of solders even melt below the 250 degrees centigrade. Solders have less tensile strength. The types of alloys are tin lead solder, tin antimony solder, tin lead silver solder. These are the solders we can use in any solder system. Lead is mainly used as a diluent only to lower the cost. The wetting phenomena is depend on the tin only. The higher the tin content, the better would be the wetting. So the wetting is the important because when wetted, the both joints are bonded together. The tin lid soldier, you can see the how it is, what is there. The next one, how it is given the tin system is there. You try to see once what happened is there. Cooling off must come down to the lowest temperature of the range of a complete soldering of the alloy. If a solder joint is disturbed during solidification, it becomes unreliable. A solder with a narrow melting range for the soldering of electronic components chosen, since wide range solder increases the soldering time. You can see the characteristics of tin lead solder. You can see 100%, 63%, and 37%, 100%. The overview, you can see what is there. That is the characteristics. You may have the other solder systems also there. Tin antimony, tin lead antimony, tin zinc, and tin silver is there. You can see that tin lead antimony, tin silver. This is a different solder system. We try to see that tin lead silver, tin zinc, and the low melting point fusible alloys also we can use. So these are the different tins we are used for joining the leads. That is a very important, we need to use that one. After discussing about soldering alloys, what alloys we are using, now let us discuss about the soldering fluxes. What is a soldering flux? Soldering flux. During the soldering operation, an auxiliary medium is mostly used to increase the flow properties of molten solder or to improve the degree of wetting. Such a medium is called the flux. What we are doing is the solder is melting. That melting property is increased. For that we use some medium. That medium is called as a flux. Soldering flux. How it is? Soldering flux. The characteristics of soldering flux are, you can see, it should provide a liquid cover over the materials and exclude air up to the soldering temperature. It should dissolve any oxide on the metal surface or on the solder and carry such unwanted elements away. It should be readily displayed from the metal by the molten soldering operation. Residues should be removable after completion of the solder. It should reduce the surface tension of molten solder and spreads well. So these are the corrosive fluxes are there. We having the corrosive or acid fluxes consist mainly of inorganic acids and salts. They are used to solder difficult materials. At place where rapid wetting by molten solder is required, at places where surface conditions are critical, when lead based solder are used, they should be only be used on components in conduction where the residues can be completely removed after soldering. The most basic ingredient in this type of fluxes is zinc chloride. We may have the so many fluxes are there, intermediate fluxes are there, lactic acid, glutamic acid, succinic acid, all these are we are using for the hydrochloride, amino acids also used. We also having the non corrosive fluxes. A non-corrosive flux is required where it is difficult to wash off flux residues after soldering. Wherever we don't wash off the this flux, they at that place we use the non-corrosive, because this, if it is a corrosive, it may corrosive the board. That's why we try to use the non-corrosive fluxes for electrical components, electronic assemblies, delicate instrument. We use the non-corrosive fluxes. Generally, colophony or natural rosin obtained from a particular type of fine wood contains a abatic acid and its isomers which become mildly active at soldering temperature, being weak acid. So how we can use the selection of a flux? Depending on our requirement, we can select the flux. That is the flow promoting properties of the flux, solder composition, composition of materials to be soldered, surrounding in which soldering has to take place, soldering technique, soldering temperature, properties of the flux residues, possible health hazards. Depending on all these, we try to select the flux of the solder. So we can conclude that here we can conclude that so solder should be the solder should be. After selecting the flux, now we go for the next level, that is the soldering techniques. What are the different soldering techniques? To achieve the solder joint, the solder and the base metal must be heated above the melting point of the solder we used. The necessary heat applied depends on the nature and type of the joint we are using. Melting temperature of the solder. So this is the, depending on this solder joint, we need to have the solder and the base metal must be heated above the melting point of the solder we use. The melting temperature of the solder and the flux, these are the necessary nature and type of the joint, melting temperature of the solder, flux. So general methods we can see the among the soldering method we use the among the soldering methods mentioned we will discuss the iron soldering, mass soldering. Two methods are there, iron soldering and the mass soldering. Iron soldering, this is the one of the soldering generally we use. The most common method for general soldering is the use of the soldering iron. The soldering iron, this technique has a reasonably high state of perfection as far as the design of the iron is concerned. Iron soldering. It is also known as hand soldering. It is also known as the hand soldering. You can see the soldering iron, insulating handle, the metal shank and the bit. A soldering iron consists of an insulated handle connected via a metal shank to the bit. You can know the soldering bit. The bit actually make contact with the component parts of the joint and the solder and the heats them up. The electrical heating element is usually located in the hollow shank or in the handle. Soldering irons are produced in an enormous variety of designs and the sizes. Selection of an appropriate type depends on the intended application. The key to the function of the iron is the bit itself. How the function of the bit? The bit of the solder iron has to perform the following functions. It stores heat and conveys heat from the heat source to the workpiece. It may be required to store and to deliver molten solder and often flux to the workpiece. It may be used to remove surplus solder from the joint. It is essential that the bit surface is perfectly wetted. This encourages flow of solder into the joint. When the surface of the workpiece becomes wetted by solder, a continuous film of liquid metal bridges the gap between the soldering iron bit and the workpiece. This provides a path of high thermal conductivity along which the heat can flow in the workpiece. The construction of soldering bit, we generally we can see usually how it is constructed. We can have different sizes of is there. You can see the different sizes of the soldering iron bits are there. The design also there. We having the different designs are there. You can see soldering with an iron what we need to do. So these are the steps we need to see. The steps involved in soldering with an iron. Cleaning the parts to be joined. Then apply the flux. After applying the flux, heat the soldering iron. Soldering iron at soldering temperature is held on the workpieces to heat them. The solder is usually in the form of wire, stick, or preform is available in the market. Solder is applied to the workpiece close to the bit where it should melt immediately and becomes bright and fluid. If enough solder has been applied, it will completely penetrate and fill the gap of the joint. If flux cored solder was not used, the joint must be cleaned and it must be treated with flux. The time required to keep soldering iron on workpiece is entirely depend on the nature of the joint and characteristics of the soldering iron. When the joint appears to be sufficiently filled, the soldering iron is removed and joint allowed to cool down undisturbed. After completion of iron soldering, now let us discuss about the mass soldering. Generally, mass soldering techniques are used when the large number of joints are needed. We use the mass soldering techniques. Mass soldering technique is used when a large number of joints are to be made simultaneously using a solder bath. Solder bath act as the source of heat as well as filler metal. The most important soldering technique employs some form of immersion or contact with the molten solder bath. Mass soldering technique is used in large electronic industries. The advantages of the mass soldering is high productivity, more rigorous control is possible over all the individual stages of soldering. It makes more reliability of the final assembly. This mass soldering generally used in the electronic industries. So we having so many types of are there. For this we try to we having the so many methods also there for this mass soldering. So many methods also there, so we not needed all those things in detail. The dip soldering is there, and another one is the next one is the dip soldering. We don't need like that. So we need to have the we need to have some idea about the mass soldering. So you can see the mass soldering. Already we discussed about this mass soldering. how this mass soldering is applied. So we use the mass soldering side of the boards. They're connecting leads path through the component holes. Like this, we having the mass soldering. So these are the advantages of the mass soldering. Already we discussed. High productivity, more rigorous control is possible over all the individual stage or soldering. Make more reliability of the final assembly. So this is about the soldering of the component on the PCB. So in this lesson we discussed about the how we prepare the PCB, and after preparing the PCB how we can drill the holes on the PCB. After drilling, how we can join the components on the PCB, how what type of soldering we are using on the PCB. Generally we use the iron soldering iron rod we use for the soldering for the individual circuits. For the mass production we use the mass soldering. So thank you for listening this lesson. If you have any doubt, you can ask me. I will clarify the doubts. Thank you.